Question number 11 from section 5.1. You have a system of equations. You have three equations and three variables. I'm going to use the elimination method. I'm going to label my equations A, B, and C to kind of keep them organized. And then I'm going to start off by combining equation A and equation C together since they already have opposite x's. And I'm going to combine those to get a brand new equation. I'm going to label that equation D. And then I'm going to take equation B and equation C. I want to combine those to get opposites to come up with a new equation. So equation A was x plus y plus z equals -1. Equation C is -x plus 6y minus 3z equals 12. These already have opposite x terms, so when I combine them, I'm going to have an equation with only y's and z's. Combine them, I get y plus 6y is 7y, plus z minus 3z is minus 2z, and -1 and 12 is 11. That equation I'm going to label with equation D. That's one of my new equations. Now I want to combine equation B with C. Equation B was 2x plus 6y plus 2z equals 2. And equation C was -x plus 6y minus 3z equals 12. So I want to get opposite x's. In order to get opposite x's, I have to multiply the whole C equation by a positive 2. I'm going to multiply the left and the right side by 2. So my equation B, I'm going to rewrite here, 2x plus 6y plus 2z equals 2. And then I distribute the 2 to equation C, and I get -2x plus 12y minus 6z equals 24. I'm going to combine those two equations together to get a new equation that eliminates the x terms. These are now opposites. These are opposites. So let's see what happens when we combine these equations. 2x and -2x is 0, 6y and 12y is 18y, 2z minus 6z is minus 4z, and 2 plus 24 is 26. I'm going to label that equation E. Now I want to combine equation D and equation E and get opposites, either opposite x's or opposite y's. Equation D is 7y minus 2z equals 11. Equation E is 18y minus 4z equals 26. I can get opposite z's here by multiplying the whole second equation by a -2. Sorry, the whole first equation by a -2. When I do that, I get that equation D multiplied by -2 is -14y plus 4z equals -22. Equation E, 18y minus 4z equals 26. Now I can add these equations together and get -14y plus 18y is 4y. The z's are opposites, so they're going to cancel out. And then the -22 plus 26 is 4. When we divide both sides by 4, we get y equals 1. Now we're going to take the y equals 1 and plug it into either equation D or E. I'm going to go ahead and plug it into equation E. 18 times y, where y is 1, 18 times 1 minus 4z equals 26. 18 times 1 is 18. I'm going to subtract 18 from both sides. Subtract 18 from both sides of this equation to get negative 4z equals 26 minus 18 is 8. And then I want to divide by negative 4 on both sides to get z equals negative 2. So I have my y and my z, y equals 1 and z equals negative 2. I want to use both of those to find x. I'm going to plug it back into the original first equation for x and y. The first equation was x plus y plus z equals negative 1. I don't know what x is, but I know that y is equal to 1 and z is equal to negative 2. So if I combine like terms here, x minus 1 equals 1. So that means x is equal to 2. I have all three parts for my solution and can write it as the solution to the system of equations x is 2, y is 1, and z is negative 2. I'm sorry, I did that wrong. Alright, I had to step back here because I made a little mistake here that when I wrote equation number 1, I didn't write clearly that that should be negative 1. Now, when you combine these equations together, you get, or plug in y and z into the first equation, you should get x plus 1 minus 2, that's a minus 1 equals negative 1, so you get x equals 0. So if x equals 0 and y equals 1 and z equals negative 2, then the way we can write our solution is 0, comma, 1, comma, negative 2.